Yeah, it turns out that Mr. Johansson and I have swapped roles this time. He's talked about IoT, and I'm going to talk about voice. Just that's how it goes. I'm going to talk about a couple of things I did with WebAudio and WebRTC. So for those of you who don't know me, I'm the CTO at Pipe, which is an IoT security company. We do a toolkit for making secure IoT, helping you make secure IoT devices. I come from a background of VoIP and WebRTC. I've been trying to escape it for some years, but somehow it kind of keeps dragging me back. Even the Pipe stuff is WebRTC based, so I'm kind of stuck with it somehow. But this talk, you'll be glad to hear, isn't about Pipe, or mostly not. Yeah, I know, exactly. It's actually about a couple of side hobby projects that I did in VoIP. And as I say, I can't avoid VoIP. Somehow it kind of drags me back. And the themes of this is like, it's a hobby, so it's got to be a low-cost thing. I'm not going to build a massive data center to house this thing. And I kind of want it to be secure and private, partly because that's what Pipe does, so it would be dead embarrassing to be caught doing something incompetent in that space. But also because I've spent a very long time doing secure things, and I kind of want to stay doing that, and it's just a habit. And I want to decentralize it. Most of the stuff I do is now on Raspberry Pis or smaller devices, and so I'm not going to spin this up on 100 Amazon clusters or whatever. But I also want to make it serverless, and I don't mean lambdas, I mean something lighter weight than that. So the first thing I did was, we're doing a podcast. A friend and I have started the podcast, which is basically around interviewing, and it's just gone live today. The website is a bit flaky, but it's there. Interviewing people about what the future might look like. And this came out of a conversation that I had a while ago with a guy who said that he was a modern locksmith. And I had no idea what that was. And we had an hour's conversation over a beer, and I learned a lot about locks and the future of locks that I had no idea about. And I thought this would be there are a lot of those potential conversations that would make a really good podcast. So we're trying to put that together. So we go and interview people. But it's called Distributed Future, which is after William Gibson quote about the future is here. It's just not evenly distributed yet. So the background was I want to do these interviews really frictionless. I don't want the person on the other end to feel like it's a big deal that they're having to set up their cameras and find a soundproof room or fly to Tokyo and be interviewed or whatever. I don't want to make it a big deal. But on the other hand, PSTN audio is just not good enough. If people are going to listen to this podcast on headphones, it's too annoying. Right? The quality is just not good enough. And Skype is not good. A lot of people use Skype, but it's simply not good enough as far as I'm concerned. And the platform is unstable, and there are a bunch of people who don't have Skype IDs, an increasing number of people who don't have Skype IDs. Their user numbers are falling. So that's not a good solution. In any way, you need this kind of virtual audio driver stuff. So I'd have to have a laptop that had been hacked to get it to work and whatever. So I couldn't be bothered with that. And I looked around at commercial apps, and there weren't any that did what I wanted in terms of just simply interviewing people and producing a recording. That weren't expensive. They all had some problem, or they were expensive, and they held onto your data. It's like, amongst it, I couldn't find anything I wanted. And I was annoyed about this because I genuinely wanted to make this easy to do. So I decided I was going to have to do a DIY. But there are a couple of observations there, which is everyone has a smartphone. Literally everyone I want to interview has a smartphone. And smartphones have good microphones these days. This is a change. They never used to. The old Nokias had terrible microphones. But the new stuff, all of the smartphones have actually pretty good microphones. And in most cases, really good echo cancelers. So that kind of made me think. And then you find that people actually do talk like that. It's not just in the movies, but people do talk to their phones like that. And they're using the echo canceller, they're using the microphone, and the results are usually pretty good. The speakers aren't brilliant, but and now, and this is the new thing, and this is actually kind of the big news for this talk, which is that all smartphones, pretty much all smartphones, now support WebRTC in the browser. I can assume that whoever I want to interview will have a smartphone and that it will support WebRTC. And that's new. That's a new thing. So I decided to do DIY. Anyone who wants to, it's open source, it's on GitHub, Pipe pod call. Very, very happy to get contributions to it. And the way that it works is as simple as I could make it, which is that the call setup is kind of like a peer-in. You know, you have an interviewer who creates a link, which is a random room ID, essentially. And they send the link to the guest over a shared channel they already have, how you were already communicating with them, which might be email, messenger, SMS, wire, whatever, Skype even. The guest gets the link and they open it in the smartphone browser. They accept the invite to talk and they put the phone down on the table and they talk to me. And that's it. Like, that's the total user experience. It's done as a standard WebRTC call. And I've added a little WebAudio magic to make the recording the way I want it to be. Now this is probably the best thing from the technical point of view of people in the audience who don't know what this is. This is the best thing in the talk. This is the inspector that is part of Firefox, which allows you to see where the audio flow is in WebAudio in your browser. Right? And it draws this lovely diagram of what's going on. And so in this case, we have the audio from the microphone going to a stereo panner, which pans it 30 degrees left. And then the audio from the far side that's coming from the interviewee over WebRTC coming in. It's then panned 30 degrees to the right, mixed together, dynamically compressed, so we have a better listening experience, and evens out the two somewhat. Create a single stream from that, push it out as a media stream, and then use the media stream recorder. All of these features are standard in every browser. And so then the call ends. The media recorder pushes this out to a file. We use Opus, WebM as a packaging, and Opus as the, because it's the smallest format that preserves decent audio. And there is admittedly a risk of losing the recording if the browser crashes before it's saved. But that was a risk I was prepared to take, given the simplicity that it gave me everywhere else.
And you mentioned,
and this is what it sounds like.
Kind of in love with blockchain. How did that start, and what was your motivation to get into it?
So how did I start? It started, I actually remember I was with my roommates and we received The Economist, which was with Bitcoin on the front. And we were reading about it, and it was so abstract to comprehend what it was that I was just like, this is another world.
So that's one of our interviews, and she's now marketing for one of the BitChain consortia. So, but the nice thing was that it was really easy to do, and it sounds okay. So hang on, you're all you know, this is Kamailio world. What about all signaling, hosting, SIP, all that stuff? Yeah, well, afraid not. Static pages hosted on GitHub pages. Right? That's static static web pages. The random IDs that we generate in JavaScript act as room numbers. So there isn't even a server keeping room numbers. I don't need that. And they're exchanged over a side channel, so I don't need a signaling channel either for that. What I do need is something to get offer and answer exchanged. I still can't get over that because that's the design decision that we made in WebRTC. So I have to build this minimalist Rendezvous server. And it's as simple as I could make it. It takes a WebSocket connection from the client. The client asserts an identity, one of these random hex strings, and the Rendezvous server reads JSON from that, looks at it, looks for a from address, checks that the from address matches where it asserted to be from. So it's kind of basically compares those. And then the other thing it does is checks to see if it's got somebody else who matches the to address. And if it is, it sends that JSON object down to that device. And if it isn't, it drops it on the floor silently. So that's as simple as I could make it. There's no state, there's no nothing. So it knows nothing. Like, it has no secrets. I don't have to trust it. Like, the worst thing it can do is just not set a call up. And okay, it could man in the middle me because we're not using secure identities. But if we used pipe IDs, we could avoid even the risk of man in the middle. But given it's a podcast and it's going to end up public in the end, it doesn't matter. And if you don't log anything, it's GDPR clean. Right? And I had to do this because, like, we're here. GDPR. So you all probably have heard about this. You know, informed consent. Only use data as you've agreed in the informed consent. Keep it secure. Allow subject access. Delete on request. Like, all of those things that you have to do. There's a new one I learned, actually, which is great, which is that you can't be subject to legal consequences of a fully automated process. There has to be human intervention in the process. That's in the GDPR as well. Fun. Anyway, and big fines if you get it wrong. So I have a quick workaround for you for how to do with GDPR, how to avoid getting into trouble with GDPR. Really easy fix, don't collect the data. Like, if you don't collect personal identifying information, you don't have a problem. There's nothing to lose. There's nothing to steal. There's nothing to look at. You don't have to delete it. And you'd be astonished at how many services can be built not to use, to be satisfactory experiences that do not use personal information. The podcast one is an example. There is no personal information in that. It's not necessary. I can get the experience we want with random IDs. So there's that. And we built another quite similar thing for a friend of ours who has a patent that he wanted to exhibit. He wanted to get a sense of how it would really work. And so he asked me to build it. It looked like a fun thing to do. Again, it's open source, but it has a patented element in it, so be aware of that. It is a community licensing thing and whatever. But and the issue it's trying to address is that interrupting people, particularly as you get older, means that you lose your train of thought, right? And so it's really nice if you don't get interrupted, which is why it's great doing this. But it causes people to lose the train of thought. And politeness over imperfect media is really difficult. So, like, one of the advantages of video calls is you can see that somebody's trying to interrupt. But, like, with latency or imperfect video or no video, you can't necessarily tell when to interrupt and when it's polite and whatever. So what this patented thing does is it automates politeness. Basically, it does something, it's kind of like a demented echo canceller. What it does is I can speak when you're speaking, and it detects this situation, and it buffers your words until I've finished speaking, and then it plays them back to me. And conversely, the other way around, the same situation for you. You get to hear what I've said once you've finished speaking. It trims out the silences, so it doesn't, like, double the length of the conversation. And it's actually kind of almost usable. Now, what we're going to do here is, hopefully, I'm going to ping down. Actually, and I'll show you the full experience. Show you the full experience. Right, so this is the web page. Generates the same deal. It generates a random URL, which I'm now going to send to Dan. And with any luck, Dan will join us. It may not work. He asked me to remind him, and I forgot, so he may not turn up. So what you're seeing here is, and you wouldn't do this for the real thing, but you have on the right, you have the local microphone feed. On the left, you have Dan, and in the middle, you have what we're hearing. Hi, Dan. How you doing?
Hi, Tim. Hi, everyone.
So we're going to now talk over each other, and what you'll see here is that as Dan is speaking, if he starts speaking, he will get some yellow in this space. So Dan, keep talking, man. Mary had a little lamb or something. Right, so as Dan is talking, he's buffered up here, and then when I stop, we'll hear him.
I'm going to talk about Come coming up in June. and it's all about great WebRTC and web stuff. Well, why would I talk about Merry Little Lamb when I can talk about ComCon?
Yeah, sorry about that. Blew your advert there. So I'm going to get on with the presentation. I will talk about ComCon at the end, though. Cheers, Dan.
Thanks, Tim.
So what you saw there was buffered audio in the browser. So the call setup, you kind of saw. I don't think there's any surprises there. You know how that worked. The only tricksy bit is when you send the offer and the answer. It's actually reversed from where you'd expect, because otherwise you get too many clicks. This is how the media flow gets built up. And so the detail of it is here. This is a running call. And what you have is a media stream audio source coming from the microphone, going into a script processor, which is detecting speech, which sets a flag if it detects speech. And this is my side of the equation, let's say. And it sends it to an analyzer, which is drawing that scope line, and then sends it out over WebRTC. On this side, we have WebRTC Dan's audio coming in over WebRTC into a media stream source, analyzing this for one of the scopes, and then detected for audio. And if both detections say true, then we buffer it. If not, we play it out. And then the scope showing the play out and the speaker. And all of this is, as I say, in WebAudio. Now, there's some ugly stuff going on under the hood, mostly because of the autoplay ads. Autoplay ads have meant that WebRTC user experience is progressively getting worse and getting more difficult to code for, because there's a whole set of restrictions on when you can start audio in either direction and start video. You can only trigger a GetUserMedia event from a user action. So I can't go to a page and automatically start it. I have to go to a page and have the user click something. I can't start play on a video element on the iPhone automatically. I can only do that with a user click. So I can't browse to an already set up call and go straight into it. I have to have an acknowledgement from the user. Chrome audio only works, and this is a bug actually. Well, they say it isn't a bug, but it's Chrome audio only works in WebAudio if there's an audio tag in the page. You don't have to use it, it just has to be present on the page. Apparently it generates the clock source. And then the other thing which meant that sequence of offer and answer was the way it was is that offers are only valid for a minute. So you don't want to send one that's going to get ignored. You have to send it when you've got a reasonable chance that it's going to get answered. So you kind of delay it. And this bug, I think this is fixed now, but there's this wonderful thing on Macs where Safari dips the other audio sources. Like your microphone in Safari, fine, but the Chrome use of the microphone is now 10 dB down because Safari's got the microphone open. When it lets go of it, you get it back. This had me tearing my hair out. So yeah, and then this is the other one that you all probably notice, which is that WebRTC calls die when a GSM call comes in on an iPhone. Or you can, in the browser this happens, and there's nothing you can do about it in the browser. I think if you're using an SDK, there is something you can do about it. So my summary is that you can do a lot with almost no servers. Right? You can build 2 usable apps, scalable apps, with almost no servers. All of the media processing is done in the browser. All of that data is ephemeral. It's never stored anywhere. It's all done in the browser, except obviously the podcast itself. I don't hold any data in the cloud. There is no data in the cloud. I don't have a bill for that. And I can build niche communications. I can build a specific use case around a specific set of needs in the browser. And it's there on all the smartphones. It's not, this is it. I'm doing this on an iPad. This entire presentation's on an iPad because I can do this on the iPad. So, and that's only possible because of the ubiquitousness, whatever. of WebRTC on smartphones now. So that's the formal talk, but because it's like what we are, I have a little bonus extra demo. So it's not this one, it's this one. And this is actually the same thing we were talking about before, which is the idea that WebRTC now works in almost everywhere. That over there, assuming I get anywhere, is a Raspberry Pi, Raspberry Pi 0W. So it's the smallest Raspberry Pi that actually has a network in it with a camera in it. But it generates really nice H.264. So we have a stack that Pipe has built that runs media on there. And we can interface it to, with any luck, Safari on an iPad. Now, with any luck, this is going to work. Of course, it may not. We'll see. Squeaky, 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 come on. No, it's not going to work. Or is it? How are we doing over here? Still a light. Maybe we'll try it one more time. You've got to add the tension, you know.
You're a master. Done it before.
So live video from Raspberry Pi. When it works, it only uses about 10% of the CPU on the Raspberry Pi, which is pretty amazing, actually. But it's not going to work. It would have done it by now, I think. Come on. No. No, not going to work. Right, OK, give up. So anyway, that's it. But WebStack on there, lightweight WebStack on there from Pipe. Anyway, there you go. Cool. Got time for questions? Oh, yes, ComCon. So residential conference for VoIP geeks in England. In, where are we, 5 weeks' time? So a lot of really interesting people there, including the voice architect for Facebook and a couple of other people who are already here in the room, but also a bunch of other people who you won't have met. So, so the website is comcon.xyz. So remember the XYZ, otherwise you'll be going to a superheroes conference. So I don't know if I got time for questions or not. No? OK, catch me afterwards. Yeah, thank you.
We can have 1, 2 questions because we need to prepare for the panel, so we need to bring some chairs in front. So ask Tim about all these crazy apps. We have Michael here.
I was actually just wondering if the device goes to sleep if you have a call coming out of the browser. Does it have any sort of intelligence to say, don't go to sleep, I know I'm in a phone call? Or since it's initiated in the browser, does it not have that? Is it not that smart?
Right. I don't think you get a message in JavaScript. I don't think you get told. I don't think there's anything there. I don't think it's available, basically. It would be. I mean, maybe I just didn't find it, but
No, I just didn't know. That's one of the things if you have an app versus if you have just some container in a site.
yeah, I think the SDKs do that, but I don't think it's surfaced in JavaScript. Maybe it's something we should add. Anything else? No? No? Good.
Other questions? Then I have one because, anyhow, not really related, but more like the reliability of building WebRTC apps now, and because also the tweet at some point, maybe you or other clarified how reliable is to build for, I don't know, a version of the browser and then rely on the same kind of behavior for like even short-term releases from different browsers. It's now more reliable with the WebRTC
No, it's worse. The last few months has been hellish. The browsers have changed their behavior hugely every month. It's a constant battle keeping on track of that. And basically you need to be testing the beta or the canary version. You need to be developing on beta or canary, otherwise this comes streaming down on you. And the fact that there are now 4 browsers, I mean, I leave out Edge typically, but because it doesn't do the data channel, and I'm only really interested in the data channel. But yeah, no, you've got a testing load. The nice thing is that generally they break in a really serious way, so the call doesn't start. Like, it's very rare that you get a kind of minor, quality issue. It just fails totally because it rejects the SDP is typically what happens. Okay. And if you make the SDP yourself, then you're running a much higher risk. If you're just using Firefox's SDP on Chrome or Chrome's SDP on Chrome or whatever, known pairings, they will have tested that. But the moment you start messing with the SDP yourself, you really have to test it on a scarily regular, well, once a month, basically.
Okay, once a month. And then last year, I think we had also a discussion when these ad blockers can actually create a lot of problems. Is still the situation getting better or worse, like blocking access to, audio video streams and network access and so on? Any experience that you can share from?
So the plus side of that being done by the browser manufacturers is it should mean that the ad blocker people stop doing it, right? Because it's now not possible to auto start video play on most platforms unless you're, like Google have got this arcane rule change which allows YouTube to sneak under the wire. And like there's a reputation engine, so if you're used a lot, then you're fine, which kind of pisses me off immensely because it's basically letting themselves get away with it. But anyway, but the fact that those rule changes are happening means that in theory, you would expect the ad blocker guys to stop doing it because the browsers are doing their job for them.
Okay. Thanks, Tim. I was curious about the evolution during the past year. Thank you again, Tim.